Hello and welcome to another tutorial. So this time around we're going to be diving back into the world of shaders, but we're going to be doing so for a very particular reason, and that's going to be so that we can set up a system for being able to have our world, when particular objects in our world react based upon where the player has been. Now, this is something where, okay, just describing it like that, you might think, well, no, I can easily keep track of where the player is. That's straightforward. What I'm talking about is being able to do this efficiently and actually have most of the calculation, most of the work happens in a shader, happens on the GPU side, and being able to do this efficiently in very large. That's the key thing that we're looking at here with this. And I'll show it for a very simple thing in terms of the case of if a player is in a location, but it's something where we can go steps further and we can have it react based upon direction there. So if the player is in a particular location, pushing things away from them is information we'd be able to do with this. So it's about being able to capture this information, do it rapidly, do it efficiently, and then be able to have a lot of that happening in the shader. So let's dive on in. So starting point, we've got the fairly familiar first person template of mine, and we're able to move around this environment. The main thing I've done is I have massively scaled up the ground plane because I want to be working with a much larger area. So starting point with this is we need to be able to capture that output in terms of where the player is. So the way we're going to approach doing that is so let's call this player presence. So what I want to do is I want the player to have a particular object on them, and that object is going to be in a very specific layer. So this is similar to aspects of what we would do if we were doing something like a simple version for a minimap. So what I want to do is on the player, I am going to attach a sphere. Now I want to get rid of the collider, and this sphere, I want to set this up in its own layer. So I want to create a layer that I'm going to call presence input. So something that feeds into the present system, which this could be coming not just from the player then. That's the other advantage with this. This is something that if we have more things in there, it will scale quite nicely. Presence mesh. So we're going to create a shader that will sit on that presence mesh. So this shader, I want it to be really, really simple as it possibly can be. So this is going to be an unlit shader. And this is going to be my presence input. And I want to set up a corresponding material for that. So we'll just create another folder for our materials. And we'll set up a material that presence input, and then we'll switch that over to our shader in a moment. Just want to make sure in terms of with this, I'm going to call this presence input. Property wise, it's not going to have a texture. Don't need fog. So we can get rid of things related to that. I will get rid of that texture, which means we can also get rid of stuff like the texture coordinates. We don't need it. We can do the transformations, and the color is just going to be a single color. So really, really, really simple shader. We don't want it doing anything complicated whatsoever. That's the key goal with this, is that it needs to be very, very simple. So this presence input then Oh, shader, presence, and input. So that's good. Then our presence mesh, we'll switch it over to that material. And there's other things we will also do here. You don't want these casting shadows or receiving shadows, so we can switch those off. And in terms of light probes, things like that, we turn off all of the things and then change its layer to presence input. So we're turning off as much as possible with this. And the reason we're turning off as much as possible is because this is something we want it to render as fast as it possibly can. As fast as it can, so that we can do more complex calculations later on if we needed to, or we could have many of these in the scene. The goal is to have this be lightning fast. So we have something that is now in its own dedicated layer, and that is going to be using this very simple shader. What we then do is, well, our world camera, we want that to no longer render that layer, so we can pull presence input, and then we're going to set up I'm going to just create it as an empty one here. Call this our presence manager. Presence manager. And so this is going to have under it a camera. So we're going to set up a camera. Now this camera, clear flags, we want it to clear to a solid color, and we want to clear it to just solid black. Again, in terms of with the settings here, we're not needing things like occlusion culling. We're not needing HDR. We're really not needing anti-aliasing at this stage. Get rid of the audio listener. So again, we're simplifying the stuff here. Rendering path, I would be inclined to just force it to forwards, but we can use graphic settings for now is going to be fine. And then this camera, I want to rotate it so it is pointing directly down. And then I want to change this from, now in terms of height here, I'm going to position it at 50. Height does matter with this a little bit. Main thing is we want it to be definitely above any of our terrain. That's the key thing there. What I'm going to do is switch it then to orthographic. And then this size setting will control the size of the area it's capturing. And what we should see is we can go probably to, it ends up being, around 150. That will actually change a little bit once I set up, because what this is going to have is a render texture. So input, capture, camera. So this is capturing for those input entries, and we capture that into a render texture. So textures, and we create a render texture, and this is RT input, presence inputs. Presence inputs. Now this render texture, the size here directly is going to correlate with our resolution. So the larger the size here, the finer the resolution. Now this, we're going to be able to get away with having this have quite a large resolution. We'll be able to get away with quite a large size here. And I'm going to start initially with this being a 2K texture. And this is part of the reason why we drastically simplified the options there in terms of lighting and the camera, is so that we can have more bandwidth for being able to fill out this texture. So the more efficient we make that, the finer a resolution we can have with minimal impact on the game performance. And that's what this is about. So input capture camera, we link up our render texture, and that immediately will see this changes. So what we can then do is we want to adjust our scale And we can see the area that it's capturing. And what it will be is it'll end up being about 250. Should be exactly right for this size of area. As soon as I go over 250, then it should be capturing a bit more than that. Now, culling mask, turn to nothing, and then we switch it to presence input. So the only thing we're capturing is this, that little sphere that the player is in. So what we want to check is that this is actually working. So an easy way we can just quickly test that that is working is what we do is this ground plane that the player is walking on. At the moment, we've got it set to our checkerboard texture. But what we could do is we could actually switch this over to a test texture that's using this, test material. So I'm just going to create a material based upon this. Matte presence inputs debug. Because this is not a texture we'd normally use. This is purely so that we can test and see if this is actually giving us output. So what I would do then is I would bring this texture onto here. And what we're looking for is that there is a white dot on this. And we can see that there is, which is good. And as we move the player around, we expect to see that change. Now, one thing you'll notice, and this is a thing you will encounter with render textures, it's clearly offset. So input capture camera, what we often need to do is with this, we change, it's rotated by 180. It's a fairly typical thing with render textures in Unity that they are rotated. But now we have this texture updating. And what we can see is the impact of the resolution we set here. So that's 2K. If I went to 1024 by 1024, we can see much less detail. If I went to 4096 by 4096, you can see much finer level of detail. So what we use in terms of resolution here matters. It's going to make a big impact in terms of the level of detail that we see there. I'm going to switch it back to 2K for now, because that's plenty, that's sufficient. And what I will do, now that we've fixed up the orientation of the camera there, is I'm going to return the ground plane to using its previous material. So, okay, first step done. We have our input source going into a render texture. That's good. But I want to have the path, the trail that the player has actually followed. So I need this to accumulate over time. Now, a default approach that you might go for with this is, okay, well, it's in a render texture. I could sample that render texture, and then that's going to be able to be, I sample it and then I feed it back in that way. The problem with if you bring the render texture into the CPU side and actually try and sample it is that process is quite slow. So if you ended up using something like a get pixel or that on it, that's a really slow process. As soon as we have to do that, there's quite a bit of an overhead, a lag that gets introduced there. So we want to do this faster. And what we want to do is have that accumulation, that building up over time, happen in the shader. And we can do that. Now, this is where it starts to get a little bit colorful with what we do. Because we need now a plane here. And so this is going to be a plane. And this plane is going to match exactly the size of the area we're capturing. So input capture plane. Actually, yeah. Input capture plane. I think that will do as names go. And then this material we created earlier, conveniently we use this. So this will rename. Now this plane, again, the settings here we want to change on this. So we don't want it to receive shadows, we don't want it to cast shadows, we want to turn off all of these settings, no colliders, we don't want that, and there's no occlusion happening with this. So that's good so far. Now, with this plane, in terms of where we position it, well, we do want it in the center, and we want to have it positioned a bit higher up. So I would say generally around where that input capture camera is a good spot. So we're just going to increase the size of this and bring this up in height. So that's showing the output there. Now again, the material on this, standard shader is a much more full-on one than we need. It takes in lighting, things like that. We don't want that. So we're going to change this from standard to unlit texture. Keep it simple. Again, we're trying to make this stuff so that every stage of this renders as fast as it possibly can. So that looks pretty good. And actually, I'm going to call this intermediate plane. That looks good. Because then what we do is we're going to set up another layer. And this one is going to be our presence intermediate. And this plane goes into that layer. And we make sure none of our cameras are capturing that. So it is completely removed from all of the cameras capturing it. So get rid of that. So now we have another plane here. And then now we have another camera. So we're going to set up another camera. And actually, I'll duplicate this one. So this is going to be the presence output camera. So this camera's job is to generate the presence output. So again, we're going to chuck that up a little bit higher. Now that is not going to render to the presence inputs one. So we don't render to that same location. We're going to render to a different one. This one will still have another render to texture though. So we have an RT presence output that this will link to. And then this culling mask, we only want it to pick up that intermediate one. So we've got our player has a sphere on it, and that's going into our input capture one and being projected onto this plane. That plane is going to get its own custom shader in a moment. What it will do is it will take what it's got in terms of the render texture and also the one from the previous frame and generate a new texture based upon that. So we're going through a couple of layers here, but so we capture the input, then we project it onto a material that is going to accumulate it, and then we capture that accumulation, and that is actually then what we're able to feed into everything. So that's what we're going to do next, is we're going to set up this shader to allow this to accumulate. Because what we want to be able to do is as the player runs around, we want to see a trail appear here. That's the end goal with this. So the next step we need to do is we need to create, again, another unlit shader. And this is going to be the presence output shader. So its job is to generate the output for this. So presence output. So this generates the output. So it's going to, this one does actually take a texture in, but we're going to rename these textures here. So we're also going to default it. So the default texture it's got is with 0 color there. That's going to be important. So this is going to be our sources. So our input texture. So presence input, rename this. So we just want things, so that's a nice clear name. Again, we do get rid of all of the fog logic because we don't need that. We're not going to get rid of the UV coordinates this time around though, but we get rid of everything related to fog. And then we're going to rename this texture. So what this one does is this has to take in that texture and then it has to combine that with the previous version. So what we set up then is we've got these for this texture, but we're also going to set up another texture here that we'll be able to actually feed into from outside of this shader. So uniform. So we have another sampler 2D. And so this is going to be the texture for the last frame. So last frame texture. And then we have another one that is a float 4. And this is our last frame texture underscore ST. So that looks good. We also want to be able to control the rate that this builds up at and the rate that it decays at. So we're going to have a present build rate, and we'll make that a range between 0 to 1. We're not going to need more than that. And we'll start that so it builds at a pretty reasonable rate. Because if 1 is the max, 0 to 1 means over the course of 10 seconds, it'll build up pretty fast. We also want a decay rate. So decay rate, similar thing, range 0 to 1. And we'll make it decay at a similar rate as well. We might need to tweak these a bit afterwards, but that's okay. And then we have build rate and presence decay rate. Good. So we've got our key bits here. Now, in terms of with the setup here, nothing needs to change in the vertex shader. We refer to the new texture, but otherwise nothing actually changes there. Where the clever stuff happens is in the fragment shader. So, first thing we need to do is we need to get the information from the previous frame. So we can sample the data there. So text 2D. We know last frame texture is what we're wanting to sample. And we've already got our UV coordinates, so we can use that. So this is going to give us our data from the previous frame. So fixed for previous frame data. Then we have fixed for new input data. So previous frame data is what's going to have been captured on that plane that we're projecting on. So we're projecting something onto the screen, and what we do is our new input data is our copy of what we've projected onto that screen, and our previous frame data is what was already on that screen. And then we're going to merge those together. So again, presence input texture, i.uv. So now we've got our sets of data sampled. Now how we work with these, that information, is going to depend a lot upon what data we want to encode, because we've got red, green, blue, and alpha channels we could encode data into. So I'm going to assume for now I'm only going to use the red channel, but we could encode data into all of those channels. And that's what I've done before in other things where I want to actually have a lot of extra information. You use each channel separately. So you can use color information for more than just color, which is a really cool thing to be able to be doing. So what I want to do with this now is I'm going to say that my previous frame data, my new input data, I need to be able to combine these. And I might actually just grab out one component from these. So I might just have fixed previous intensity is equal to previous frame data red, and fixed new intensity or new presence. Actually, yeah, new presence equals new input data dot red. We'll call this previous presence. So we want to then work out what we actually set here, because this is going to be the default. We're going to say it's that, but I want to work out the new value here. So simplest thing would be I could combine these, I could check the ranges, but we wanted to have this ability to decay things. So what I could do is say, okay, well, previous presence, I'm going to decay this. So previous presence minus my presence decay rate times by, and we can actually access delta time. Now the delta time is a 4D vector, and the different components actually give you delta time with different calculations provided on them. This is just going to be straight delta time. So that's cool. I don't want this to be able to go too low though, so I'm going to clamp this between 0 and 1. So decay the previous presence. And actually what I'll end up doing is these will end up getting put into all of those, but that's all good. So I'm decaying the previous presence. Okay, so I've got a decayed version of the presence. I've now got a new version, and then we want to apply that new version. So for being able to apply the new version, well, we want to control that rate. So we have that build rate. So what I would be saying is new presence, and that new presence, the amount that it builds, or the rate that it builds by, is my times by presence build rate times by unity delta time dot x. So fixed, well actually it could just end up being new presence is equal to previous presence plus whatever the new value is. And then again, I want to keep that constrained between 0 and 1. So calculate the new presence value, and then I just put this into here. So I'm going to leave the alpha value at 1. I'm going to change this. So we're grabbing the previous output, we are decaying it, but capping it so it doesn't go below 0. And then we're adding in the new input. So our decay and build rates will allow us to really carefully control how long a trail actually lasts, how quickly something might react to the player's presence there. So it gives us a way of balancing that. That's what it's about. So that looks good for the presence output. That means materials here. So we set up this texture. I'm going to bring this over to here. And this is the one that's currently applied to our capture plane. So I'm going to rename this to Mat Presence Output Generator, because that's its goal. It's generating the presence output. So texture-wise, we do want it to be using that presence inputs one. So that's good. And then we want to make sure our camera is capturing to the presence output one, which is good. Now at this stage, if we grab the player and move the player around, we see the dot move, which is good. We're not seeing accumulation yet. but that's to be expected because we're not feeding in that last frame. So this is where we need to close the loop on this, and we set up the ability to feed in that previous frame. So we're going to set up a script here, presence manager. And the job of the presence manager is going to be to shuffle, essentially, that data. So presence manager is going to need a couple of things because it has to take the data and hand it over to the other object. So first thing it needs is it needs the material, and it needs the material for that presence output. So presence output, because that's what it's having to actually feed to. Also needs the render texture, and this is the render texture for that previous frame. So last frame source, and then what we're going to do is we're going to, and what it has to do is reasonably straightforward. We set up a texture 2D, and this is our last frame copy. So this texture, we initialize this. This is our last frame copy, is a new texture 2D. Now we can pull the settings for this from our render texture. So our last frame source dot width, our last frame source dot height. We can then also grab last frame source graphics format, and then we pass in the Unity engine. So in terms of this, texture creation flags, none. We're not needing things like bitmaps, anything like of that for it. So we create texture that's going to hold our shadow copy essentially. Then what we do is in update, we do graphics copy texture, and we copy from our last frame source to that temporary one that we created, that last frame copy. So we do that, and then we do shader.set global texture. And if you remember the name we had to use here, last frame texture, we use that, and then we give it last frame copy. Now, this graphics copy texture is something that different platforms, you will have different things that it might be capable of. Now, in the case of typically on Windows, Mac, it's pretty safe that this will run GPU side, which is what we want. So it's able to be really fast because it's copying from a render texture just to a texture that's not having to do any CPU side operations. So this is really quick. But that is something where you do want to check on your particular platform of what's going to be viable there. So if we want to check what things are supported, we can actually query systeminfo.copy texture support. That will indicate what things are actually supported with the graphics copy texture one. So that can be a useful thing just to be checking if you need to. But this is something where on Windows and Mac, as I said, this will be able to run GPU side. So now we can link up our materials. So the presence output generator goes to this. And our last frame source, well, that is coming from the presence output render texture. So this is the chain that we've got. We have a sphere on the player. That sphere is able to only be seen by the input capture texture, the input capture camera. So that camera can see the sphere on the player. It takes that, it puts it in a texture, and then it applies that texture to this intermediate plane. Now we then have another camera sitting above that that captures what is currently rendered on that plane. So then that shader that is on that plane is using a bit of C# code there to have the last output that was captured of what was on that screen filtered back into it so it can merge it and blend it in together. So it's a bit of a windy path, but it gets us what we need. So I'm going to bring the game view down here because we want to really be able to see our scene view. And then we're going to test so we can see where we're located. And then we want to move. So it is moving with us, which is good. That's the sort of first step with this. And then we want to get it so that it is combining and layering each successive frame after the other. So this is something where we can check then our material, because with this, we're still using the unlit texture one. So we want to switch over to our presence and our presence output one, which means we need to link that up to the appropriate render texture. So if remember, render texture wise, this gets the presence input one. And then we test with this. So now when we move, we're seeing nothing. And this is a common thing that we can easily run into. Remember, we set up some stuff here for the decay and build rate. So what we need to do to get this running, because what's happening is it's actually decaying too rapidly. So we up our build rate to 1, and then let's run this. And with it running, so we can see the dot there, and importantly, as I move, we are creating a trail behind us. So we are able to have this reacting based upon where the player is. Now that decay rate is obviously not decaying quickly enough, but we can also, one of the advantages with this is we can adjust this while it's running. So let's up that decay rate to 0.5. It's probably a bit of a better decay rate. And we can see now it's decaying fairly quickly. So we can probably go for a bit of a lower decay rate than that. So we might drop that decay rate down maybe to 0.25. And we might allow a faster build rate. So we did keep the build rate fairly limited, but we can change this. So, okay, let's allow it to build and maybe even decay a lot faster. That's all good. And then we run this, and we might find that ramping that build rate up to maybe 2 might work better. So we can see that builds quite quickly. We can see it decaying. And it decays. We can see the decay process there happens a lot slower for ones where we spent a lot of time there, which kind of makes sense that it would take a while. But we could ramp that up again. So I think like 0.5 and maybe even up to 5 for the build rate. So it'll build really, really rapidly, which means it'll react to our presence quicker. But it'll also decay fairly quickly. And that feels pretty good. So we've now got something that, okay, cool, it's on this texture, whatever. That's not really that impressive yet, because I want something appearing on the ground. So now we get to the final part and the really sort of cool part with this. So I'm going to set up a shader. And this can be any type of shader now at this stage. So I'm going to go for it being a standard surface shader. And I'm going to call this a presence ground shader. And so this is going to be presence, and we'll call this ground. And we'll switch the material over for the ground to that. But what I want is that the ground will actually, and we can zoom back down here because we know that this is working properly, so it can go under our plane. I'm going to switch this shader over to our presence and ground. So, it looks exactly like it did before, which it should. Now, I want to have it be pulling information from the shader. And I don't need to do anything extra, because with this set in global texture, that means every shader has access to last frame texture. Every single shader has access to that, which is great. That means that every single shader is going to be able to grab that information, be able to use that for what it needs to do, which is perfect. So for them being able to do this, I need my presence ground shader is going to, what we set up for this, it's a couple of things. One of the key things we need to set up is a sampler. So similar to what we were doing here, and we can actually take exactly this presence ground shader. I'm going to put these in here. And presence system support. So, okay, that's cool. Tag this nicely. Presence system support. Begin. Now, key thing with this. When we were sampling in the other ones, we had UV coordinates, we were using planes, was easy. We don't have that. We need to be able to generate our own UV coordinates, which means we need a couple of extra little bits of information. So one of the things is we need to know our origin point, and we also need to know our world scale. So we're going to have a uniform, and this is going to be a float 4, presence, texture, scale, and a uniform float 4, presence, texture, origin. So we can work this out. We've got our presence manager here is going to feed these through. So we'll end up with a couple of other things here. We will have a shader set global vector. And I think we can guess what the names of these are going to be. The 4, we'll pass the info into that in a moment. Just want to get these set up. So we need to have then configurations for these. So serialize field, vector 4, presence, texture, scale, and a serialized field, vector 4, presence, texture, origin. We can just pass these in. You might be wondering, okay, you're doing shader set global, are these things expensive? Not overly, they're pretty cheap. They're something that's not going to have a particularly high performance impact, which is great. So we can configure these. Now we could auto detect these, but we can also work this out just manually. So if we take a look at our setup, we want to know essentially that far corner, which an easy way of doing this is we chuck in a sphere, and I'm pretty sure it's going to be at something like 250 by 250. Yep. So that means that other corner there is likely going to be minus 250 minus 250. Perfect. So that means our origin point is going to be minus 250, 0, minus 250. And our texture scale, well, we want something that's going to allow us to convert from a world space coordinate into our texture UV coordinate. So I'm going to make this 1 divided by 500, so it's able to just be a multiply. And we'll do 1 divided by 500. Cool. So our shaders will have that info now, and this means all of our shaders will have that info, which now we can use that. Because what I want to do is I want to affect the color based upon the location here. Now, one of the things I am going to need is I do then need in my surface shader here, I need my world position. So that's something where I need to have the world position. So to access our world position, we just have float3 world pos. That will automatically get filled in. So then what we want to be able to do is we want to have a function here. And this function's job is going to be to get our intensity. So it's going to be focus on, here's our location, give us the intensity. Float get presence intensity. We want to have it that we provide it float3 world pos. So what it needs to do is world pos minus presence texture origin XYZ. That gives us our local pos. So float3 local pos is equal to that. Then we can sample our texture. So similar to what we were doing here, text 2D, we sample last frame texture, and then our coordinates here are going to be a float2. So we have local pos.x times by presence texture scale.x and local pos.y times presence texture scale.y. That will sample it. And we only need the red component, so we can just return. That means we can get our presence intensity now. So then we can say get presence intensity in.worldPos, and let's adjust the color here. So I'm going to set up a presence color. Default that to, we've got kind of a bluish green color. So let's actually go for a fairly intense red. Should do nicely. So we have a fixed 4 for our presence color. And what we'll do is we will lerp our albedo based upon that. So o.albedo, we lerp from, we can just do c.rgb to our presence color based upon that intensity. So the more we are present in a location, the more it should be tinting it towards that color. So that looks pretty good. Should sample the intensity. So it should mean that once I actually fix up the typo, then, now it will often look incorrect initially. That's okay. We don't need to be alarmed. Now we can see that it appears correctly. And what we're wanting to hopefully be able to do is as we move around, see that we get color changing. Now, one thing we do want to watch for is, because we're going through a lot of render textures, things like that, very, very easy that we might have things rotated. So the reason we're running into issues with it working is really easy problem to run into when we're working with coordinate systems. These need to be Z. So local pos X and Z, like that. Now, if we run this, what we're going to do is we can see is appearing there. And like we ran into before, stuff can be rotated. So that's something that really, really easy to happen, where our coordinates end up inverted with the setup there. So that's something where we can take our cameras and we can often rotate those. So it's usually going to be the case where if we change that camera, it's going to be one or other of the cameras that needs to be fixed, and I usually just rotate one of them and see. But now our ground is changing based upon where we've been. And in terms of taking a look at the performance input, so let's switch fully to the game view and we'll turn on the stats and let's run. So what we're looking at is, okay, we've got 10 set pass calls is generally what we're hitting. Got our texture there, we're hitting a pretty solid frame rate. So we're moving around, set pass calls pretty consistently, always around that 10 value. Let's turn off all of the present system so it's not generating any data. And then we'll run again. So 2 less set pass calls. So the cost of it is pretty cheap. If I add in additional meshes that it could be rendering here, so if I add in extra ones, put those at different locations, sort of offset, you can do stuff that really makes the player think things are chasing them. So having more things in there, no impact in terms of performance there with it off, which you'd expect. We turn it back on, and what we'll see is no difference in terms of the number of set pass calls there, because it doesn't matter how many of these presence meshes we've got. They're pretty cheap to be working with. Now we can also set up here, we don't need a depth buffer with these. So again, a little bit more stuff that we can get rid of that will simplify the process for it. And then still running as it did before, same number of set pass calls, good frame rate. And the final thing we're going to do is let's ramp this up to 4096 by 4096 for each of these. So we are quadrupling the amount of pixels we're working with, which will give us slightly finer trails. And you can see it's a bit more detail in those, but performance-wise, we're not seeing a huge difference because this process, we've made it as efficient as we possibly can. And we can easily control that decay rate, but that's pretty good where we can be running and we still get a bit of a trail behind us. So we've got our setup. So just to recap how this works, because there is a bit of a convoluted process that stuff threads through. So I just want to recap that. So first step, we have our things that can be present. So these things that can be present, they have their own dedicated material and mesh. And that mesh is only seen in a particular layer. So it's confined to its own layer. We set that mesh to be as simple as it possibly can be from a rendering point of view. So we get rid of shaders, we get rid of receiving of light. We use a shader that is a very, very, very minimal shader. We could do extra stuff in it, like encoding directional information, but for now, we're just keeping it super simple. So we have that really straightforward. The presence mesh, that is seen by this input capture camera. So it can only see those presence meshes. And again, it's set as an orthographic camera. It captures the full environment. And we've, again, turned off a bunch of things that we don't need so that it's able to run as efficiently as possible. We've also gone and lowered the depth of it. So it's the first camera in terms of the order there. With that set, what we then do is we're able to take its output and it goes into a render texture. So now we've got a render texture that's seeing where these things are. We take that render texture and we project it onto a plane. This plane is our screen that we use for building up our presence data on. So we have a specific shader on that screen that takes that new input, is provided directly into it. It also gets given, here's what was previously on that screen. Now shaders can't capture that directly themselves, but we can do that with a little bit of logic in code. So that plane, that screen, effectively has shader on it that takes our previous frame, takes our new input, and merges them. It decays the previous frame, and it applies the new frame at a particular build rate. That build and decay rate allows us to control how rapidly we build up presence and how quickly it fades away, which it directly is going to control how long the trail is and how quickly stuff can react to us. So we've now got a screen that what is drawn on that screen is our final presence output, but we need to get that efficiently to other things in our game. We want to avoid having any of it happen CPU side. So what we do is we have a final camera that is, again, really quickly set up in terms of being able to render as fast as possible. It takes the output from that screen, puts that in another render texture, and then we have a little bit of C# code. That C# code's job is, first and foremost, it shuttles the texture around. So it grabs that copy of the previous output on that screen and provides that to the shader, and also provides it to every other shader so that other things can use it. It also then provides through location information so that other shaders, like we set up with our ground one, can easily query a location and say, hey, give me the data at this spot, give me the intensity here, so that we can use that information. And that allows us to stuff that we could do then in any shader. We could migrate these functions into a CG ink that we could then include in other shaders to make it really easy to access that stuff. So it makes it a straightforward process for us being able to access this data and do so really efficiently, which means we could have things in our trails on the ground. We can have lots of stuff that's reacting based upon where the player has been, which is cool. We can encode extra information. We're only using the red channel and only for intensity. We could be controlling, having a lot more stuff there in terms of direction and other information there, which can be really handy. So that's the key setup that we've got for this. So the code for this project, like with all the other projects, is fully available up on GitHub. You're free to use this code in any of your own projects. It's there set up in a nice modular way, so dive in and experiment with it, see the kinds of cool things you can do. If you've got any questions, then please do chuck in a comment below. And if you found the video helpful, please do chuck in a like and subscribe. It really, really does help out. And if you're looking for other ways to support the channel, then I do have a Patreon, and the link to that's in the description below. Bye!